Where does the universe end? This question has haunted humanity since we first gazed at the stars. We only see a fraction of the cosmos, as if peering through a tiny window. But does this window have a frame, a boundary beyond which nothing exists? Science tells us that we can only see what is called the observable universe. Its boundary is set by the speed of light and the age of the cosmos. Everything beyond lies hidden, like pages of a book we have yet to unfold. When we observe distant galaxies, we are in fact looking into the past. The light from the farthest objects has taken billions of years to reach us, yet there are worlds even farther away. Their light simply hasn't had time to arrive on Earth. If we could instantly teleport to the very edge of the observable universe, we would not see emptiness, but countless more galaxies. Out there, space continues, but for us, it is hidden behind a veil of time. Scientists call this the cosmic horizon. It is not a physical wall, but the limit of what is visible. Beyond it, the universe may be infinite, or it may possess a shape we cannot yet even imagine. Many scientists believe the universe may be infinite. If so, no matter where we stand, there will always be more space, more stars ahead of us. Yet infinity is difficult to grasp. Our minds are wired to expect a beginning and an end. But there are other ideas. The universe could be finite, yet without an edge like the surface of a sphere. Imagine traveling straight ahead, only to eventually return to where you started, without ever crossing a boundary. Mathematicians call this idea a closed space. It is like a vast room, without doors or windows, where you can move forever yet remain inside. Perhaps our universe is built in exactly this way, doctors, to test these hypotheses. Scientists search for repeating patterns in the sky. If the same galaxy appeared in different places, it could mean space is closed. So far, however, no such repetitions have been found. Still, we do know the universe is expanding. This discovery changed our entire view of the cosmos. The farther galaxies are from us, the faster they recede, as if the very fabric of space itself is being stretched. This expansion began with the Big Bang, about 13.8 billion years ago. Space and time were born in a single instant, and since then the universe has never stopped growing. With every second, it becomes larger than it was before. Astronomer Edwin Hubble was the first to observe this astonishing phenomenon. In 1929, he showed that galaxies are moving away from one another. His discovery became the key to realizing that the universe has both a history and, perhaps, a future. Today we know, the farther a galaxy is, the faster it moves away from us. This is called Hubble's law. It shows that space itself stretches like rubber, carrying stars and planets along with it. This means the observable universe has not only a boundary, but also an age. We cannot look back beyond 13.8 billion years, because before that there was no light, and no space to carry it. And still the question remains, what lies beyond this horizon? There may be an infinite number of worlds we will never see, or or space itself may be limited like a vast yet finite sphere. Some scientists suggest that beyond our horizon lie regions of space similar to our own universe. This is part of the multiverse theory. It claims there may be countless universes, each with its own laws. In one such universe, stars might burn brighter, while in another, they may not exist at all. Somewhere the physical laws resemble ours, elsewhere they are completely different. We can only theorize, but testing this remains impossible. But even if no other universes exist, our own still holds countless mysteries. We do not fully know how it is structured, or how it will end. It may expand forever, or someday collapse into another Big Bang. There is also the idea of the Big Rip. If expansion accelerates endlessly, then in the distant future, it will tear apart galaxies, stars, and even atoms. The cosmos would lose the structure we know. To predict the fate of the universe, scientists study dark energy, the mysterious force driving its accelerated expansion. It makes up about 70% of the cosmos, yet its true nature remains unknown. Scientists measure dark energy with space telescopes. They observe supernova stars, which act as beacons across vast distances. From their brightness and rate of recession, we can understand how the universe evolves over time. The results are astonishing. The expansion of the universe is not slowing down, it is accelerating. This means the cosmos will become colder and emptier in the future. Galaxies will drift so far apart that their light will never reach us. We live in a unique moment. The universe is still full of light, and we can witness its beauty. But billions of years from now, the cosmos will look very different. The night sky will become empty and dark. This fate is called the heat death of the universe. In the far future, energy will spread evenly, leaving no stars and no motion. The cosmos will freeze in eternal silence. For now, we live in an age when the universe is alive with activity. Stars are born and die, planets form, galaxies collide. For us, the cosmos is not a cold void, but an endless source of discovery. Every new discovery in astronomy brings us closer to understanding where the universe ends. But perhaps there is no end at all. Maybe we are part of an infinite tapestry that never breaks. When we look through a telescope, it is like peering into the past. The light from distant stars shows us the universe as it was billions of years ago. The farther we look, the older the picture becomes. There is a certain poetry in this. We never see the universe here and now. For us, it is always a memory, captured by light. And perhaps beyond the horizon lie chapters we have yet to read. To learn more, we build ever more powerful observatories. The James Webb Space Telescope can see farther than any before it. Its mirrors capture the light from the first stars and galaxies. With it, we are pulling back the curtain to glimpse the opening acts of the cosmic drama. It reminds us that the universe is not just a mystery, but a story we are still reading, and each page amazes the imagination. Yet even the most advanced telescope will not reveal the end of the universe. It only deepens the mystery, uncovering new horizons. The more we see, the more we realize how much remains hidden. Physicists believe space may be curved. If so, the cosmos could be closed in the shape of a torus or a higher dimensional sphere. These models are hard to imagine, yet they arise naturally from equations. Sometimes scientists say the end of the universe is an illusion. We search for edges in three-dimensional space, but space itself may be built differently. What appears to be a boundary may be only a shift into another form. For us, it is like an ant walking across a sheet of paper. It thinks it is on an endless flat surface, yet it is actually moving on a curved plane. Perhaps we are travelers just like that dot. Every step of science reveals new levels of understanding, but each answer gives birth to dozens of new questions, and the question of where the universe ends remains one of the most thrilling. One way to look further is by studying the cosmic microwave background. It is the faint glow left from the first moments after the Big Bang. Like an echo of the universe's birth, it still fills all of space. This ancient radiation tells us the cosmos was once hot and dense. Over time, it cooled, giving rise to the first stars and galaxies. It is as if we can still hear the echoes of creation's cradle. But even the cosmic background does not show us the full picture. It only reveals what the universe looked like 380,000 years after the Big Bang. What happened before that remains a mystery. Some physicists suggest the existence of cosmic inflation, rapid expansion in which the universe grew immensely in a fraction of a second. This theory explains much, yet it remains a hypothesis. If inflation was real, then beyond our horizon may exist infinite regions of space, each one like its own universe, with its own history, and we can see only one of them. If infinite regions exist, then somewhere there could be worlds like our own, perhaps galaxies, stars, and even planets astonishingly similar to Earth. But they will forever remain beyond our reach, philosophers ask. If we can never see these worlds, do they matter to us? Science replies, yes, because their existence helps us understand the very structure of reality. It is a question not only of astronomy, but of philosophy. At times, it feels the more we learn, the less we truly understand. The universe is in no hurry to reveal its secrets, yet this is what makes its exploration endlessly fascinating. We stand as if on the shore of an endless ocean, seeing only the first waves. Beyond the horizon lies an abyss full of wonders and mysteries, and each discovery we make is a small step in an infinite journey. Where does the universe end? Perhaps this question has no answer, yet the very attempt to solve it turns our curiosity into the driving force of science. We live on a remarkable era. Never before has humanity been able to look so far into the universe. Each new telescope reveals pages of the cosmic book we are only beginning to read. Our discoveries affect not only science, but also our sense of self. We realize Earth is just a tiny dot in the vast ocean of space. Yet this very awareness makes our existence all the more precious. Every generation asks, where are the boundaries of the universe? Perhaps future scientists will uncover new answers. But even if we never know the truth, the search itself makes us part of the great mystery. This is the greatness of the cosmos. It gives us endless questions and endless inspiration. We do not know where its limits lie, but we know that striving to find them makes us human. The universe may be infinite, or it may have a shape we cannot yet imagine. But in any case, studying it is also a story about us, about how a small mind seeks answers in the vastness of space. Where does the universe end? Perhaps we will never know the answer. Yet the journey of searching is humanity's greatest adventure. And as long as we look to the sky, the cosmos will never feel empty.